Welcome to What the Fact. Today's topic is this. I have a green laser here, and what I'm going to do is show you some footage of me shining it. We've been blessed lately with some extremely dense fog, so last night I just went in my backyard and was shining the light around. Just a quick aside, look at what happens when I shake the laser back and forth. Clouds and fog are made of just droplets of water. When I shake the laser, you can see the individual droplets. I just thought that was cool. Light always travels in a straight path, which is why the laser beam looks like this perfectly straight line. You can see that when the laser beam hits this prism, it changes direction. This is known as refraction, when a wave changes direction as it passes through a different kind of material. This happens because different materials are of different density, so the light goes through those other objects at a slower speed. Acrylic is obviously much denser than air, so the laser beam slows down and changes direction as it goes into the prism. This is why a pencil can look broken when it's placed in a cup of water. The light from the pencil doesn't go directly towards you. It goes this way a little bit and then towards your eye. You can see here that when I shine the laser into water, it changes its angle, but then when it leaves the water and goes through air, it goes back to that original angle again. Wait a minute. This is really bizarre if you think about it. It makes sense that the laser beam slows down when it hits water or the prism, but why should it change directions? Why can't it just move slower and then travel in the same direction? And the change in direction is not caused by the glass in the tank. Here you can see I'm shining the laser beam straight into the water and it still changes its angle. The light beam is obeying something known as Snells Law. You know that the shortest path between any two distances is a straight line. When I shine the laser beam in the air, that's exactly what it does. It goes from point A to point B in a straight line, the shortest path. But what about the quickest path? Let's say you want to go from point A to point B, but between you and point B there is a lake. Obviously, the quickest path is going to be to go around the lake, which is a longer path, but it'll obviously take less time. Clearly, the fastest way to get to point B is to take a longer path by going around the lake. It may not be the path of least distance, but it is the path of least time. This is why GPS directions can be confusing sometimes. One of these routes is several miles longer than the other, but they take virtually the exact same time, because you can go faster on the roads on the longer route. In truth, light doesn't take the shortest path. It always takes the path of least time. Sometimes those are the same thing. That's why the laser beam's a straight line when it's going through just one kind of material. But when the laser beam hits water, it changes direction so that it can end up at its destination in the shortest amount of time. Fermat's principle is the observation that light always does this, taking the path of least time. Snell's law is the mathematics behind how this works. It describes the angles that light forms as it switches from one kind of material to another. Take a look at the laser here. You can see that it starts here at point A and ends here at point B. When the laser hits the water, it makes a pretty dramatic change of direction. This makes sense when we think about what's happening. Light can't travel as fast in water versus air. If light traveled directly from point A to point B, then it would spend more time in the water and it would take longer for that beam to get from point A to point B. So instead it changes direction to spend the least possible amount of time to reach point B. I don't know what you think about all of this, but to me it's almost spooky. The fact that light always takes the path of least time makes it seem like there's some sort of goal in mind, like the light beam is doing it on purpose. But a beam of light can't have goals, it can't do things for a reason, it can't be conscious, right? Well, we don't know what consciousness is. The only thing we know about consciousness is that we're pretty sure we have it. Consciousness is a product of the brain. Brains are just physical things. So is a beam of light, in the wave-particle duality sort of way. Bacteria don't have brains, but they do specific things. Bacteria themselves don't have reasons for doing things, but they do things for reasons. Perhaps they're conscious at a much lower level than we are. Maybe in the most basic and fundamental sort of way, so is a beam of light. Thanks for watching.